Air pressure is the force exerted, applied simpler, by the weight of a column over above a particular location. Examples of the air pressure are drinking with a straw and injection. Okay, now let's begin. The experiment's title is Stuck Like Glue. The materials that we need are water, paper towel, white mocha, lighter, a plate, and small pieces of a paper. Okay, let's start the experiment. First, fold a paper towel into a square or rectangle that is slightly wider than the mold of a white mocha. Wet the folded paper towel and lay it flat in the center of the plate. Tear off a small piece of normal paper, roughly the size of a sticky note. Use a lighter or match to light the small piece of paper on fire and drop it in the white mold jar. Immediately, flip the jar over and into the wet paper towel. Firmly press the jar into the paper towel and plate, letting the lid piece of paper go out. When the piece of paper inside the jar is completely extinguished, lift the jar and see what happened. The white mold jar and plate stuck like glue. When the flaming paper is extinguished and you add pressure into the jar, the adhesion and cohesion of the water create an airtight seal between the plate, paper, towel, jar, and water. This airtight seal means that air is constantly trying to push its way up and into the jar without success. The air pushing at the seal creates the phenomenon of the plate sticking to the mold of the jar. And this experiment relates to Bernoulli's principle.
Bernoulli's principle is really important in physics and all types of sciences. Bernoulli's principle states that as the velocity of a fluid increases, the pressure exerted by that fluid decreases. Now what that means in practical terms is that a slow-flowing fluid exerting more pressure than a fast-flowing fluid. This means that in a moving fluid, pressure and velocity are inversely proportional. When one is high, then the other is low. If the other is high, then the other is low. This is exactly why when you're in the shower curtain will stick to your leg. And it's because the fast-moving water from the shower head creates an area of low pressure, which causes the shower curtain, which is in that area of low pressure, to stick to the nearest object, which happens to be your body. The principle also applies to airflow. One of the most dramatic everyday examples of Bernoulli's principle can be found in the airplane. This is the reason airplanes stay in the air. Lower pressure is caused by the increased speed of air over the wing, and the area of pressure under the wing is higher, the wing is pushed upwards, thus making the plane stay in the air, stay afloat. You see, air moves faster over the upper surface, which causes the air pressure to decrease. The lower air pressure over the top of the wing gives it lift, but some air is directed beneath the wing, which the lift must exceed the weight if the aircraft is to fly. So the final example I have today for you guys is a clip I took by myself. It is a blow dryer demonstrating airflow with a 2-liter head, the nozzle I cut off and attached to the blow dryer, and it makes a ping pong ball float in the air almost magically, and even tilting it out to almost 45 degrees, as you'll see in the latter half of the video, that it can still stay afloat because it's in that area of low pressure. And so it will stay afloat just like an airplane will. Thanks, guys.